Do you know what's interesting about web development? It's that you think those websites, the sites that win awards and prizes, are impossible to build on your own. That it's only reserved for elite agencies or teams of a dozen people with 20 years plus of experience in web development. They want you to believe it's out of your league so that they can keep charging clients $50,000 for websites. But let me tell you something. What if you could simply copy and paste every mind-bending animation, the best techniques, the most complex transitions, and the best-looking effects directly into Webflow in just a few seconds? Not only to learn how to create these techniques yourself, but also to be able to create the websites you've always dreamed of for your personal portfolio or your clients. The kind of websites that would leave both Apple or Google speechless, wondering, how the hell did they manage to do that? Seems too good to be true? Well, think again. With Honoric Components Library, I want to share with you the best kept secrets of web development in order to make them accessible to everyone. I want to help you build outstanding web experiences at unprecedented speed, inspired by the world's best designed websites. And I'm not joking, seriously. On this channel, I'm going to release the most advanced tutorials ever made on web development so that everyone can benefit from them. But enough talking, grab a cup of coffee, and let's get started. In this first tutorial, I will teach you how to recreate a magnetic button effect you see on some of the most beautiful award-winning websites. This tutorial is part of a more comprehensive training on creating web experiences that I will be publishing soon. The page you see right now on the screen is inspired by a website I love very much and whose animations I find absolutely incredible. So I decided to recreate it in Webflow using my own techniques and my own universe. In fact, the page you are seeing right now will be one of the pages I'll teach you how to create from scratch in Webflow. Of course, there will also be other web experiences with 3D animations, complex shaders, incredible transitions, and other effects that absolutely no one teaches you how to create online. I am really looking forward to releasing this training, and I hope you find it useful. If you would like to be notified when this course drops, you can join the waitlist on the Honoric website by signing up to the newsletter. The first 50 people to sign up will receive an exclusive promotion when the training course is released. And if you're lucky, maybe it will already be published when you watch this video. By the way, the magnetic button effect you are going to recreate today is actually one of the many components already present in the Honoric library. It's called Muse Magnetic Button Effect 01. If, for any reason, you get stuck following this tutorial, or if you want to save time by copying and pasting this effect directly into Webflow in just a few seconds, you can do so by registering on the Honoric website. Otherwise, you can continue watching this tutorial, where I will teach you how to recreate this effect entirely on your own. You can also join the Honoric Webflow community on School if you want help from other community members, or if you want to contact me directly. It's completely free, and the first members to join will receive a surprise. The link is in the description. So today we will use Webflow, of course, S3, and CloudFront from Amazon Web Services to store, access, and serve our website medias and scripts, and GSAP for animations. If you don't have a Webflow account yet, you can sign up for the free plan, which allows you to create 2 sites in your workspace so that you can follow this tutorial at no additional cost. Let's start with a new Webflow blank project. I'll begin by importing the font I'm going to use in the site settings. In the Fonts section, I'll import the Sego UI semi-bold font. On Windows, you can find it in the Sego UI folder in the default Windows Fonts folder. Of course, you can use any other font you want. It's just an example. Here, I'm just renaming the font so it's easier to find it in Webflow. I'm selecting a font weight of 600 and Arial as the fallback font. Now let's open the Webflow project. Select the body div and add a div block under it by typing Ctrl-E on Windows or Command-E on macOS and typing div block. Let's give it a class name of page wrapper. Next, add a second div block under it and give it a class name of page main with a main tag in the settings tab. Then below page main, create another div block and give it a class name of Muse Magnetic Button Effect 01. Then under it, create another div block and give it a class name of Top Wrapper. Then another div block at the same level with a class name of Bottom Wrapper. Select the top wrapper div and change the display to flex and the alignment to center. Then give it a height of 50 SVH. SVH stands for small viewport height. 50 SVH means a height corresponding to 50% of the user's viewport, taking into account the fact that browser controls, such as the navigation bar containing the site URL, are visible. Then do the same thing by selecting bottom wrapper. Next, select the top wrapper div and change its background color to a gray color. You can copy the value I'm using or choose another color you like. Then do the same thing for bottom wrapper and change the background color to a slightly lighter gray than the previous one. Now let's start creating the buttons. Select the top wrapper div and create another div block under it. Convert it to a link block by right-clicking on it, then give it a class name of button group. Next, select button group and create a text block under it and give it a class name of text button. Then select button group and create another div block under it and give it a class name of button BG, which stands for background. Select button group and change its position to relative. Then select text button and change its position to absolute. Select button BG and also change its position to absolute. Next, select button BG and change its z-index to 0, and select text button and change its z-index to 1. Next, select button group and give it a size. You can use the values I use on the screen or use your own values. I use values with VW, which stands for viewport width, so that the size adapts to the width of the user's viewport. You can use fixed values in pixels or more complex values with the clamp function. For this tutorial, I'm keeping things simple by using VW. Then, change its display to flex and its alignment to center. Next, select button BG and change its absolute position to full so that the background occupies all available space. Next, select text button and change its font to the font imported at the beginning of the project. For me, it's the Sego UI semi-bold font. Also change the text color to black. Next, select button group and in the typography section, change decor to none to ensure there is no underline below the button text. Next, select text button and set the font size. You can copy the value I'm using or use your own value. Now let's change the text in the text button block to Contact Us, for example. Next, select button BG and change its background color to white and its border radius to 80 pixels. Next, select bottom wrapper and create a div block under it, then convert it to a link block and give it the button group class. Also, I think I forgot to show this in the video, but on the button group, change the overflow to hidden and change the border radius to 80 pixels. Next, select button group and create a text block under it and give it the text button class. Next, select button group and create another div block under it and give it a class name of button overlay. Select the button group again and create an embed code block. This will be the block into which we will import our video. Give it a class name of Clouds Video BG. Select button overlay and change its position to absolute. Then select Clouds Video BG, open the code embed editor by double-clicking on it, and copy the HTML video tag you see on my screen. It is a rather straightforward HTML video tag that sets the video playback parameters and the size and position of the video. In the SRC tag, which stands for source, I have already placed a CloudFront URL because we will later see how to store the video in AWS S3 and access it through CloudFront. We will update the URL with our personal CloudFront domain later. Of course, if you use a different host, modify the URL to suit your situation. And if you're wondering why I don't just use the background video block already available in Webflow to place my video on my Webflow website, it's because Webflow compresses videos hosted directly within Webflow by default. However, this compression is often too strong and the quality of the videos is degraded too much. That's why I use another host. Just to show you, here's a preview of the video we're going to import, a simple video background with clouds moving. If you want to get the video I'm using, you can click on the link in the video description or go to the Oniric website. Here, scroll down to the home page and sign up for the Oniric newsletter. You should then instantly receive a welcome email. You can then scroll down to the bottom of the email and click on the Get Your Free Assets button right here to get all the free assets that will be used in this tutorial and in all the upcoming tutorials on the channel. Once that's done, let's go back to our project and set up our Amazon Web Services account. Creating an AWS account is fairly straightforward. Just follow the steps on the screen and enter your information. If you're wondering why I use AWS in particular as a host, it's because unlike other Webflow-specific services that charge you based on the number of videos or assets you host, AWS has a pay-as-you-go billing policy. However, you get a fairly generous free tier, which means you'll never pay anything if your usage remains reasonable, which will be the case if you just want to host assets for your personal projects. In my case, during my first 6 months of using AWS, I had hundreds of videos and scripts hosted on it, and I was never charged a penny. Once your AWS account has been created, go to your console by clicking on the Sign Into Console button. Then, in the search bar at the top of the screen, type S3 and click on the Buckets link. Amazon S3 is the AWS storage service where we will store our media and scripts for our website. A bucket is simply a storage unit, similar to a folder on your computer. Let's create a new bucket by clicking on the Create Bucket button. Next, give your bucket a name. For the sake of this tutorial, let's call it Oniric Tutorial. You can then leave the other settings at their default values. Keep in mind the block public access settings for this bucket section, as I will explain later what these settings are for and why we keep them checked. For now, all you need to understand is that if you uncheck these settings, all the assets you host in your bucket will be publicly accessible on the internet by anyone who knows your bucket's Amazon URL, which is not what we want. Next, click the Create Bucket button to create your bucket. Next, click on your newly created bucket. Let's be organized and store our objects in appropriate folders. Click on the Create Folder button to create a new folder. Give it a name of Muse Magnetic Button Effect 01. Then, inside this folder, create another one in the same way. Give it a name of Public and click on Create Folder. Then, in the Public folder, drag and drop the Clouds button video to trigger the import. You can leave the default settings and click on the Upload button to import the video. Once it's done, let's now create what is called a CloudFront distribution. For now, just follow what I'm doing on the screen, and I'll explain later why we're doing this. Click on the search bar at the top and type CloudFront. Then, click on the CloudFront link, and then click on the Create a CloudFront Distribution button. Next, give your distribution a name, such as Oniric Tutorial Distribution, and a description if you wish, then click Next. For the origin type, you can leave Amazon S3. In the S3 origin section, click Browse S3. Select the S3 bucket you created earlier and click Choose. You can keep the other settings at their defaults. Keep in mind the Allow Private S3 bucket access to CloudFront setting. We will come back to why we leave it checked later. Click Next to proceed to the next step. Click Do Not Enable Security Protections and click Next. Finally, click Create Distribution to create the CloudFront distribution. Once this is done, you can see the custom CloudFront domain linked to the distribution. Let's copy it and paste it into the source tag of our video tag in our Webflow embed block code. Before continuing, let's briefly explain what we did on AWS. In our S3 bucket, where the video is hosted, you can access the Amazon URL for this video by selecting the video and then clicking the Copy URL button. If you then try to open this URL in your web browser, you will get an access denied error message from the server. This is due to the block public access settings for this bucket parameter that we left checked when creating the S3 bucket. This makes the objects stored in our bucket private and inaccessible, even if you know the Amazon URL of our CloudFront bucket or the objects inside it. The problem now is that with the current settings, no service can access our objects, including our website. To fix this issue, we created a CloudFront distribution. Amazon CloudFront is what is known as a CDN, which stands for Content Delivery Network, whose role is to distribute our content to users across a global network of servers. Remember, when configuring our CloudFront distribution, we specified our S3 bucket as the origin. The origin is the location where CloudFront will fetch our content to distribute it to users. In addition, during the CloudFront configuration, we left the Allow Private S3 bucket access to CloudFront setting checked, which allows CloudFront to access the contents of our private S3 bucket and distribute our assets stored for our website. You can verify this by trying to access the same video stored in our private S3 bucket, but through the CloudFront domain linked to the distribution we created. As you can see, by copying the URL of my video's location into my browser through my CloudFront domain, I am able to access the video. The advantage of going through a CloudFront distribution is that it is then possible to apply specific policies to the distribution, for example, by allowing the distribution to access certain folders in the origin and blocking access to other folders or other types of content. If you're interested, I can make an advanced explanatory video on how to use CloudFront and S3. Let me know in the comments if you'd like that. Now let's go back to our Webflow project. In the bottom wrapper div, click on Text button and change the text to Contact Us. Next, let's create a temporary div block and give it a class of text color white. This is a utility class that we will use as a global combo class, which we are using here to change the text color to white. In Webflow, a combo class is a class that inherits the styles of a base class. They are a great way to create variations of this base class. Once that's done, select Text button inside bottom wrapper and apply the combo class text color white to it to change the text color to white. Then you can delete the temporary text color white div because we no longer need it. Now let's publish our site to see where we are. Okay. Everything is displaying correctly, including the video. Great, now let's make the buttons responsive. Inside the top wrapper div, select Text button and select the tablet breakpoint by clicking on Tablet at the top of the project. Then change the text size. You can copy my values or use your own. Then select Button Group in top wrapper and change its size. Again, you can copy my values or use your own. Next, let's move on to the horizontal mobile breakpoint and do the same thing. Change the size of the button group and the text size of the text button. Finally, let's do that again for the mobile breakpoint. Let's publish the site to see where we are. It's not bad, but the white text on the bottom button isn't visible enough. To fix this, select Button Overlay in bottom wrapper, change its background color to dark gray, and change the transparency value or alpha value to 20. Let's publish the site again to see the result. Great, now the button text is visible enough. Now let's move on to setting up our development environment so we can code the custom code needed to implement the magnetic effect on our Webflow buttons. Start by creating an empty folder wherever you want on your PC. Next, open your favorite IDE, and inside it, open your empty folder. We will then create 3 files that we will complete later. Let's name the first one customjs.html. Let's name the second one custom css.html. Next, let's create a scripts folder, and inside it, let's create the third file, which we'll call magneticbutton.js. The custom CSS HTML file will contain our custom styles. Once finished, we will copy the contents of this file into the inside head tag section of the custom code tab in our Webflow page settings. The custom.js.html file will contain the JavaScript code to be executed when the page loads, as well as the import of our other JavaScript scripts that we will host on our Amazon S3 bucket. Once finished, we will copy the contents of this file into the before body tag section of the custom code tab in our Webflow page settings. Finally, the magneticbutton.js file will contain the JavaScript code to implement the magnetic button effect. This file will be hosted on our Amazon S3 bucket and imported by the code in the custom.js HTML file. Let's create a scripts folder in our S3 bucket. This is where we will place our script once it is finished. If you're wondering why the magnetic button JavaScript code isn't directly implemented in custom.js HTML and placed directly in Webflow, it's because Webflow's custom code has a length limit of 50,000 characters, which is easily reached when the page has multiple effects or animations. In addition, for personal organizational reasons, I prefer to separate the different scripts and import them separately into my final site. Of course, this is a matter of personal preference, and you can do things differently if you want. Let's start by coding the contents of the custom.js file. We will start by coding a load script function, which is a small utility function that will allow us to dynamically inject an external JavaScript file into the page at runtime. It accepts three parameters. src for source, which is the URL of the script to load, is async, a flag that decides whether the script should execute asynchronously, and is defer, a flag that determines whether the script should be deferred until the HTML has been parsed. We default isAsync to false and isDefer to false, so if we don't pass values, the script will load in the normal synchronous way. Inside the function, we create a new script element by calling document createElementScript. This is how we dynamically create script tags with JavaScript. We set the source attribute of that script element to the source parameter that was passed into the function, and we set the async property on the script element to the value of isAsync. When isAsync is true, the script can download and execute independently of the rest of the page. If false, it won't use the async behavior. Next, we use an if statement. When isDefer is true, we set sDefer equals to true. A deferred script waits to execute until after the HTML has been fully parsed, but before the DOM content loaded event. This is great for scripts that don't need to block the initial rendering of the page. Then, we add an onload handler to the script element. This function will run only after the external script file has successfully finished loading. Inside the load handler, we check document ready state. If it is not equal to loading, that means the DOM has already finished parsing. In other words, the document is either interactive or complete. If the document is no longer loading, we call document dispatch event to manually fire a DOM content loaded event. This mimics the native event that browsers fire after the HTML is parsed. We then append the script element to document body by calling document body appendChild. This physically inserts the script into the page, which triggers the browser to fetch and execute it according to the async or defer flags. Next, we add a script tag that loads GSAP from a content delivery network. We will use GSAP when implementing the magnetic button effect after. Then we open a new script tag. The code inside will run immediately in the browser. We check the viewport width using window match media min with 991 pixels.matches. If this expression is true, it means the viewport is at least 991 pixels wide, a common breakpoint to target desktop devices. We use this condition to subsequently import the script implementing the magnetic button effect on desktops only, since the effect is based on interaction with the mouse and is therefore not compatible with small devices. Next, we call our load script helper to load the magnetic button script that we will code just after from our host. I have already written the URL because I already know where I will host the script once it is coded. When importing the script, we enable the defer parameter. This ensures the magnetic button script waits until the HTML is parsed before executing, which avoids blocking initial rendering and reduces layout thrashing. Now let's code the contents of the magnetic button.js file. To begin with, we start an IIFE, an immediately invoked function expression. This creates a private scope, so our variables and functions don't leak into the global window scope by accident. It helps avoid naming conflicts with other scripts. We then use an if statement as guard clause. to verify if GSAP is present. If GSAP isn't available on the page, we exit immediately to avoid errors. Next, we define a lerp function, which stands for linear interpolation. It eases a value from a to b based on a factor n between 0 and 1. If n is small, the value moves slowly. If n is larger, it moves faster. We'll use this to smoothly animate position and scale. We then declare a function called initMagnetic, which is the initializer for a single button. It receives a DOM element button plus an optional configuration object. We use object destructuring with a default trigger factor of 0.5. Trigger factor controls how close the mouse must be to the button's center to activate the magnetic pull. By using button query selector, we look inside the button for an element with class text magnetic. This is the label text that will move and scale slightly when the magnetic effect engages. Keep in mind that we will need to add the text magnetic class to the text of our buttons in our Webflow project for the effect to work. Then we also grab BG magnetic, a background layer of the button. We'll transform this too for a fuller effect. Again, we will need to add the BG magnetic class to the backgrounds of our buttons in our Webflow project for the effect to work. The if statement just after is a safety test. If either element is missing, we stop and avoid running the rest of the logic. This protects against markup variations. Here, we keep track of the latest mouse coordinates in this simple object. It starts at 0, 0 and will be updated on mouse move. Then, prop stores all animated values we want to smooth over time, translation on the X and Y axes, and scale for overlay and text. Each property will hold the current target cure, the previous rendered value prev, and an amount value, which is the interpolation speed, indicating how fast we lerp. TX is the horizontal translation for the button, and TI is the vertical translation. Scalo stands for overlay scale. It starts at 1, no scaling, with a slightly faster interpolation than TX and TY, 20%. Scale T stands for text scale. Also starts at 1 with the same interpolation speed as scale O. Then we define hover, which will tells us if the mouse is currently within the magnetic radius. It starts as false by default. Rect will store the button's bounding box, retrieved from the browser. As for rad, it is our magnetic radius. That is to say how far the mouse can be from the center to trigger the effect. Next, we define updateRect, a function to recalculate layout metrics that can change when the page resizes or elements transform. Here, we measure the button's position and size relative to the viewport. This gives us its center and dimensions. And here, the magnetic radius is computed as a fraction of the button's width. With the default trigger factor of 0.5, the radius is half the width, forming an activation area around the center. We then call updateRect to immediately calculate rect and rad on init, so we have correct values before any mouse movement. We then add a listener because on window resize, the button's size and position can change, so we recompute rect and rad to keep the effect accurate. Next enter is called when the mouse moves inside our radius. It sets up the hover state and triggers scale changes. With the if statement, we verify if we're already in a hover state, so that we avoid doing the enter logic twice. This prevents redundant animations. By using GSAP kill tweens of we stop any ongoing GSAP animations on the overlay and text elements to prevent conflicting tweens. This ensures a clean transition when entering. Here, we set the target text scale to 0.85. On hover, it will add a subtle shrink that adds depth and responsiveness. We then animate the text immediately toward the hover scale using GSAP for a smooth, eased transition. Then leave is called when the mouse moves outside our radius. It reverses the hover state. We then add a listener. We listen to mouse movement over the whole window. This gives us continuous X and Y mouse coordinates, even if the pointer is slightly outside the button, which we need to calculate proximity. We then define a start request animation frame function, a small helper function that starts the animation loop, but only if it isn't already running. Our RFID stores the current animation frame ID or null if no loop is running. We then define render, which is our main animation loop. It updates measurements, computes forces, interpolates values, applies transforms, and decides whether to keep looping. It starts by verifying if the button has the data magnetic disabled attribute. If so, we temporarily disable the effect by resetting all transformations and stopping the loop. This is useful if you need to turn it off dynamically, for instance during modals or transitions. Still inside render, we call updateRect to recalculate the bounding rect each frame. This keeps the center accurate if layout or transforms affect the element's on-screen box. Then, we compute the horizontal and the vertical distance between the mouse and the center of the button. In the next line, we compute the distance with a vertical weight. By multiplying dy by 2, we reduce sensitivity vertically. This creates an oval activation shape that feels better for button layouts. We then initialize tx and ty to 0. This is the new target horizontal and vertical translation for the button this frame. Then, we verify if the mouse is within the magnetic radius. If so, we engage the effect. We switch to hover state and trigger the hover-specific animations. Here, we set the horizontal target translation. We push the button toward the mouse by 35% of the distance from the center. The 0.35 factor keeps the movement subtle and controlled. After, we do the same for vertical translation. The combined effect is a gentle pull toward the cursor, like a magnet. Here, if the mouse is outside the radius, we disengage, return to the non-hover state, and animate back to defaults. We then update the target curve value for X and Y translation. Then, we iterate over every key and props. For each property, we ease the previous value toward the current target using our lerp function and that property's smoothing amount. This is what creates the smooth, fluid motion instead of a jump. We then apply the ease translation to the button itself. We use Translate 3D to leverage the GPU for smoother animations in most browsers. We then start building the text transform. We translate X and Y by 1.1 times the button movement. These slightly additional movements will enhance depth. Then we apply the eased scale to the overlay. Even though we don't change scalo.cure and enter or leave in this version of the script, keeping this line allows future variations if we want the overlay to grow or shrink. Next, we compute still moving, a boolean indicating whether anything is still animating or the mouse is still hovering. If we're in hover, we should keep updating. If the X or Y translation isn't near 0, for instance when still easing back, we keep looping. Or if the text scale hasn't fully returned to 1, we keep animating until it does. These small thresholds prevent micro-oscillations from running the loop forever. Then, by using an if statement, we verify if any of the conditions above are true. If so, we request another frame. Otherwise, we stop the loop to save CPU and GPU resources. Then, we use a listener. When the mouse enters the button area, we kick off the request animation frame loop. This ensures instant responsiveness. We also start the loop on mouse move over the button. On some platforms or edge cases, mouse enter might not fire reliably, so we use this as a fallback. Here we publicly expose the initializer on window. Now any script can call window init magnetic button element if needed to attach the effect to a new button. Next, when the DOM is fully parsed, we initialize all existing buttons. This ensures the elements exist before we query them. We select all elements with the class button magnetic. These are the root elements that should behave like magnetic buttons. We will add the button magnetic class to our buttons just after in our Webflow project. Then, for each found button, call our initializer to wire up the effect. Let's finish by coding the contents of the custom CSS HTML file. This one is pretty straightforward. We open a style tag and include an only screen and min width of 991 pixels media attribute. This tells the browser to apply the enclosed CSS rules only on screen devices that are at least 991 pixels wide. In other words, the following styles are desktop only. As a reminder, we are doing this because the magnetic button effect is only compatible with desktop. We will then apply styles to the 3 classes that we used in our magnetic button JS script earlier, and that we will add to our Webflow project shortly. For button magnetic, text magnetic, and BG magnetic, the will change transform is a performance hint to the browser. It tells the rendering engine that this element's transform is likely to change soon, through animations or interactions, so the browser can prepare optimizations like promoting the element to its own compositor layer. For text magnetic, pointer events none disables mouse and pointer interactions. We use it on text magnetic so that the text cannot be selected by the user. Finally, for BG magnetic, transform origin center defines the pivot point for transforms on this background element. By default, transforms pivot from the element's center in most cases, but explicitly setting center ensures consistent behavior across browsers and future refactors. When we scale or rotate, it will happen around the center point, keeping the motion balanced. Next, let's go back to our Webflow project and add the classes needed for the magnetic button JS script we implemented to work. In top wrapper, select button group and add the button magnetic class. Next, select Text button and add the Text Magnetic class. Then, select button BG and add the BG Magnetic class. Next, do the same for the bottom wrapper button. Select Button Group and add the Button Magnetic class. Then select Text button and add the Text Magnetic class. Next, select Button Overlay and add the BG Magnetic class. Let's finish by importing our scripts. Let's go to our S3 bucket, and let's place the Magnetic Button JS script in the scripts folder of our bucket. Drag and drop the file to trigger the import, then click on the Upload button to import it. Next, copy the contents of the custom CSS file and paste it into the inside head tag section of the custom code section of your Webflow page settings. Finally, copy the contents of the custom JS file and paste it into the before body tag section of the custom code section of your Webflow page settings. Then, let's publish our website. And here are the results. Beautiful. A wonderful magnetic button interaction. Congratulations on getting it done. You have now completed the implementation of an award-winning magnetic button effect with Webflow and custom JS and CSS code. And you have also learned how to configure Amazon Web Services S3 and CloudFront. Feel free to like and subscribe to the YouTube channel, as I will continue to regularly publish numerous tutorials to teach you how to create effects that are much more complex than what we saw today. Thank you very much and see you on the next video.